paperwork, copying train orders and things like that. And so they spent a considerable amount of money, especially in busy corridors, upgrading to a system where a remote operator could control trains on a territory using signal indication. This also, oddly enough, in the model railroad world is super helpful because our traffic density on our model railroads is often so incredibly high and our train runs are much shorter. That is, by the time you leave a staging yard and run across the layout on most railroads, it's, a 10 or maybe a 15-minute run at most. And copying 2 or 3 or 4 or 5 orders to do that often can lead to considerable delays, especially if you have multiple trains out there. So the name of the presentation is CTC and its implications. I'm Stephen Priest. I'm the Chief Operating Officer at Class1modelworks.com, and I'm also a lifelong super avid model railroader. Love model trains, always have, and this is the story of building a CTC panel as it related to our last railroad, the St. Louis Division. So as I mentioned earlier, a lot of us in our journey of model railroading will start out with an orbiting railroad or an orbiter, which basically you're running things kind of in a circular pattern for entertainment. As you progress in the hobby, you will more than likely want a little larger railroad and maybe a little larger railroad. And eventually, if you keep going with the hobby, you'll end up with a large railroad. And one of the nice things about the larger railroad is then you can start implementing operations. In other words, you can start running that model railroad just like the prototype railroad, where instead of a train just running in circles, it actually just runs across the railroad one time from a staging yard across the railroad to another staging yard. And the nice thing about the larger railroads, or even medium-sized railroads, you can operate on medium-sized, smaller railroads too, actually. But the operations get more interesting, obviously, the larger and the more interesting the railroad is. So this is not a scalar issue. It's an issue of being able to have multiple operators. In other words, multiple locomotive engineers out on trains on a railroad, and how are those locomotive engineers told what to do? How are they informed as to what their actions are going to be? Well, that's what signaling is all about. Signaling really serves two purposes. The first thing is it's to provide authority, which means, hey, your signal's green, you can move now. And then it provides protection, which means once you move, the signals behind you and the signals in front of you turn red to keep other trains from coming and hitting you. So authority and protection are the two big things that we talk about when we talk about signaling. I've run for years on other people's railroads. That's the nice thing about operating, is you tend to spend a lot of time running on other people's railroads. Seen a lot of operating approaches, a lot of paperwork systems, a lot of signaling systems. CTC, for me, is by far the most enjoyable form of railroading, operating, and literally dispatching your railroad. I really like CTC. It's a lot of fun. We built the first panel with the Emporia subdivision. This is a shot of it here in 2000. It was a relatively small panel. The railroad I had designed, if you look at the panel itself, was about half double track, and then there were a few single sidings, a couple long ones and a couple short sidings across the railroad. There were a couple other things that I want to point out real quick, and that is if you look down below in the panel, you'll see that there's a couple smaller little panels down below in black. Those panels are the staging controls. So the dispatcher on the layout controls, once he calls a crew to get on a train, he can control their departure from the staging, then their trip across the railroad, and then they're re-entering the staging on the other end of the railroad. So we put that into the CTC panel as well, because those are things that the dispatcher should control. This is a time lapse of Mark Steenwick running the large panel that we built for the last railroad, which was the St. Louis Division. This was a very big railroad. It was a 22-minute run one way if you never stopped. So coming out of staging, running across the road to the other staging, if you never stopped your train, it was 22 minutes. It had multiple, numerous sidings, double track, triple track, and of course a variety of yards. And it was a very fun railroad to dispatch. Here's a picture of the layout. Um, Again, one of the things that CTC does, or making a system where your dispatcher can talk to the train crews via a method, which in our case we're doing it with signals, and we'll talk about that here in a bit. CTC, and I'm going to say, put this in parentheses, frees your railroad. And what I mean by frees your railroad is it frees the operators. It also teaches them signaling, but it really creates some autonomy when you're running the railroad, when you're running across the railroad, because literally the train crews themselves, with minor exception, only have to interface with the dispatcher if they're going off a signal territory into a yard or coming on, or if they have work, or if they have an emergency or a train failure, such as a broken knuckle or something like that, then they need to communicate with the dispatcher. Because of this, the dispatcher can run many, many, many more trains, many more operations across the railroad or railroad in a shorter amount of time, and that's super key, especially on a model railroad. So why CTC? Well, I've explained some of these things to you, but I want to get a little more in depth. It really deals with managing communication. It provides operators the availability to control train movements. I've been at a lot of railroads where you'll call a model railroads, where you call a crew of 10 or 12 people, and most of them spend a lot of time sitting around in a chair waiting to run their trains, because the control operator just cannot keep up with the amount of traffic or the level of trains that need to be run. And that experience is not really excellent for your train crews or the operator itself, because what you're doing when you're having an operating session in a lot of ways is you're entertaining your friends, and you want them to have a good time. You want them to get out there and be able to run trains and operate, and which is the main reason they're there. Again, in order to move a train, you have to have some type of permission or authority. And one of the earlier systems is track warrant systems, where basically it's kind of a mother may I system, where the dispatcher will set a set of limits that your train can move in an eastbound direction from Abe to Bess. And once you get to Bess, you'll have that's the end of your warrant, and you'll need to contact me again to copy another warrant. And that's a fantastic system, and it works really well, especially out on the prototype. But it's a challenge for a smaller model railroad, because time is compressed and operations are compressed. When I used to run to Superior, Nebraska on the BNSF, formerly the ATSF, as an engineer, we would copy a track warrant when we were leaving the main line at Peabody, heading towards Superior, and that may be the only warrant we'd copy that whole day. Now, if there was another train out there, we may copy another warrant. We may have one meet, or we may be following another train. But I mean, we would literally spend 8 hours a day or 6 hours a day on one warrant, which is the way the track warrant system really works. On a model railroad, I've noticed a lot of dispatchers just almost get warrant burnout from copying and canceling warrants. And it's not a bad system if people like to run that way, if they want to be really laid back and relaxed that way, or if they have no interest in CTC or the expense, because there is a considerable expense both with signaling and with time and electronics and a lot of things like that. So there is an expense to it, but the trade-off is the higher amount of traffic that can be run. You really can entertain people a lot better on your railroad. So it's very interesting when we have a system where we're copying warrants or copying track warrants, or have a dispatcher that all the communication is being handled via radio, because what you end up with is this entire plethora of questions. You know, where am I? How many cars do you have? Where are you? When is my departure? What are my limits? What's my train? All these things. And again, the idea behind CTC is to lessen this and in a prototypical manner as well. And the interesting thing is when we talk about track warrants are definitely, and timetable and train order, they're definitely prototypical ways to run a railroad. No doubt about it. They are 100% prototypical. But CTC is prototypical also. And the prototype railroads solved the problems that they had, the exact same problems that a lot of us have on the model railroad, in the same way that we as model railroaders solve, and that is they implemented some form of automatic train control or CTC or some ABS or something like that that allowed them to have a more robust modicum to move more traffic. So how does this work? What happens exactly? So you have a dispatcher that sits at a board, and basically the board is a map of your railroad, and the dispatcher is going to control really two things on that map, hence on the railroad. The first thing he's going to control is he's going to control how the turnouts on the main line or any turnout that is entering the main line, how that turnout is set, if it is normal or reverse. And then the second thing he's going to do is he's going to route the train by either to the right or to the left on the panel with another layer. So basically, or excuse me, another lever. So what he's going to do is he's going to either set the turnout for normal or reverse to create a lineup or basically a route, and then he's going to line a train to the right or to the left across the railroad. And he doesn't have to go all the way. He can take the train from a point to another point, stop him there. Or if there's no traffic ahead of him, he can take them all the way. Or he can take them, put them in a siding, stop them in a siding in the clear, or he can stop them on the main in the clear so we can have a meet and another train can can pass them there. And of course, depending on how high your traffic is, how heavy your traffic is, you may have several meets. Then basically with the meets, you get into an issue of prioritization of trains. Trains with a higher class or greater authority are going to move across the road at the derision of lesser trains who are going to spend a lot more time in the sidings. AKA the hot piggyback trains are going to do a lot better than the lowly grain trains. So in this image, you'll see a dispatcher. That's Mark Steenwick. He was a fantastic dispatcher. He's at the board, basically controlling the boards. Through the CTC panel, if you look on the image of the gentleman sitting in the F unit, they're going to get their information through line side signals. So Mark will make a decision. He will put that decision into implementation with how he sets the levers on the board. He'll push a send button, and that will go out to the railroad, and the signals will be set to his discretion. There's also there's an awful lot of safety features built into the CTC panel. You cannot line two trains onto the same track. Physically or electronically, the system will not allow you to tell two trains to occupy the same track. Also, you can't run trains through the wrong way through a switch. If you're trailing point through a switch and you're on the main and the reverse route is lined, you will get a red signal there, and the dispatcher cannot line you through that turnout until the route is set to normal, and the panel lets the dispatcher know this. So it's a really, really good system, relatively simple system to operate off of. So again, there's Mark again. He's going to set a lever there, and the line side signal out on the railroad is going to let Phil there go ahead and take off out on the main line. And that's basically how it looks. Phil doesn't have to talk to Mark on the radio. He doesn't have to tell him anything. Doesn't have to tell him where he is at because the track is detected. Mark knows exactly where he's at. Mark will keep a list of the trains on his territory just so he knows, you know, if it's the 199 train or the Super C or the 130 train or whatever, so he knows where things are, what the trains are. But the location is automatically indicated by the panel, by the map at the top of the panel. So again, that signal lever right there equals a signal setting. So the dispatcher lines a route, and the train crew gets a green or a yellow to proceed. And it's as simple as that, and no verbal communication is required. So let's talk a little bit about the effects of CTC on a model railroad operation. This is a panel in Pine Bluff, Arkansas that we went down and studied. They have a whole, this is former Cotton Belt SSW Railroad panel. There's a museum there, and they have all of the panels off the SSW. I believe all the panels, most of them. A couple things about the prototype panels that I did not model, and most people don't, because it's such a neat investment to build a panel that you want it to be all nice and shiny and clean. Actual prototype panels are really beat up. There's tape all over them. There's all kinds of stuff. There's probably, a quarter inch of nicotine from, the dispatchers that smoke, chain smoke they're really filthy machines. And of course, the other thing is they're basically in service 24 hours a day from the time that they go into service to the time that they're removed from service and junked. Literally, it's incredible the amount of time that these things spend in service running 24/7, 365. The railroads don't shut down on most mainline railroads now. I will say all mainline railroads don't shut down on the weekends. I mean, it's a 24/7 operation. So, effects of CTC on a model railroad operation. Obviously, we've talked about the improved traffic flow. That's huge. The correct use of signals. That's really cool. Your crews get to learn how the actual signals actually work. It was really cool raising my son. He helped build a lot of this panel, and you'll see a lot of his pictures in this later. He did a lot of the programming with a fantastic gentleman by the name of Bill Carr, who wrote a lot of the code for the railroad. And it was really neat to go rail fanning with Joel in later years, because Joel knew exactly what was going on train movement wise on the prototype, because he had sat down and built the panel and helped program it. And it was really cool that from the model railroad experience, he went out to the prototype and was a much better rail fan, a much more effective rail fan, because he knew what was going to happen prior to it happening. So far less crew downtime. Crews come to your house because they want to run. And people like to sit around and BS a little bit, but they really come and they want to run. And CTC allows that to happen. Markedly less radio traffic. We use little handheld walkie-talkie radio handsets. And, we were having operating sessions before the CTC was 100% in. And oh my gosh, the radio traffic is unbelievable. Anybody that's doing Mother May I railroads understand this. They realize that. We've talked about the ability to run far more trains faster, quicker, more efficiently. A vastly improved interface between the main lines and the yards. And let me explain this to you a little bit. There are actually different authority figures that control the main line and control the yards. The yards are under a different management group than the main lines are. So where the yard ends and the main line begins, there's an interface. And so basically we've set our CTC panels up so the yard master or train master or whoever's in charge of the yard pushes a button which puts a request telling the dispatcher, hey, I've got a train ready to leave the yard out on the main line. And then the mainline dispatcher will push a button that will then allow the CTC machine to go out and look at the territory, throw the switch, and clear the train out of the yard. Conversely, the same thing is true. If the dispatcher has a train that is going to be yarded, he can't just line a switch and just dump it in on top of the guys in the yard. He has to push a request button that will then basically allow the yard master to go, oh, I've got a train that has been requested to come in. So he can clear one of the leads, open the track up, and open one of the receiving and departure tracks up, line the switches, push a button, and let the dispatcher know, okay, I'm ready for you, the train can come in. So there's an interface between two management authorities there with the yard mainline interface. And that's really cool to watch happen. There's a lot of, us model railroaders are ornery people. There's a lot of ornery interface between the main line and the yard, just like there is in the prototype. I'm not going to say animosity, that's the wrong word, but there's a lot of kidding and joking and teasing that goes on with that interface. So anyway, and then of course the last thing is it's a far more realistic train crew experience because most mainline railroads now run with some form of signaling. So let's build this. And when I say build this, the panel, not dam. So we're going to talk about the physical aspect. Now that we've talked about the psychological effect and the actual physical effect on the railroad, we're going to talk about a few things that you need to think about, obviously, with your panel. And the first is where to locate your panel. On the St. Louis division, I had an area underneath a stairway. You'll see, if you look to the left of the image, you can see the stairway coming down into the room. This was actually in the crew lounge, and it was separate from the railroad room. So the dispatcher had a fairly quiet place where he could operate, but he could call crews because they were right there as well. But he was removed from the railroad, so physically he had that separation. Just like most dispatchers are. Most dispatchers are in a building or in a room someplace. They may have a window that looks out to the railroad, but that's about it. Most of the time, most of their territory is far removed from their vision and their direct interface except through the panel. So we designed basically a table system, kind of a table and then a panel that sat and tucked in up underneath that stairwell. Here's the track layout of the railroad, and if you'll notice where that pink arrow is, that's the dispatcher that sat underneath the stairs out in the railroad lounge. So, in order for the dispatcher even to see the railroad in real time, he'd have to stand up, walk around the stairway, open a door, and go into the railroad room. So he actually was removed physically from the layout. So from the onset of the project, there were a lot of things that I wanted to have happen for dispatcher. Again, one of the things that experience tells you as you run at different railroads around the nation, as you go and run on other people's railroads, experience their railroads, one of the things that you begin to do, if you're paying attention as a designer, is you begin to say, oh, you know what, it may not be a big problem, but I want to design around that. And so I began to put a mental list of things I wanted to design around to make better problems to solve, basically, in order to make a really good dispatcher experience. So obviously a separate room, good lighting, adequate airflow. This is huge. The airflow situation, dispatchers are very busy and it's often kind of a tense position. So they're nervous and they tend to be you tend to run a little warm in those situations because you're busy and you're thinking about things and you're chewing on things and you have a certain modicum of nervousness. I wanted hard flooring, such as a hardwood flooring, so that a chair could be rolled around easily in the room. And then, of course, to make things prototypical, I wanted some wainscot around the wall. The wainscot also protects the plaster wall, so as you're backing chairs up, you're not dinging your wall up. You actually have a chair rail in wainscot. And you can see as I was building the room there, some of these things were happening. So the other thing is lots of desktop space. You want a lot of desktop space so we can spread things out. The lighting, we decided to do passive lighting instead of direct lighting. We wanted kind of some bounce lighting. So here's a couple more shots of that. The desk space was a nice burl oak table that actually was in the house when we bought it. It was kind of a big desk space that was up in one of the rooms. We kind of cut it down and cleaned it up, resanded it, refinished it to become the dispatching support table. And then we built another little portion of the table that went off of that in an L shape. But this kind of bulbous end was really nice. Of course, in this picture, it's got all kinds of junk laying on top of it. But we had a nice railroad lamp there with an Adlake lamp underneath it. And then we always had paperwork or some things there. It was kind of a nice spot, nice area. The indirect lighting, basically, we used some kind of antique 1930s lighting fixtures with silvered light bulbs. So these are light bulbs that are silvered on the lower half of them so that there's no direct lighting. Everything is bounce lighting or indirect lighting. Also, if you look below the lighting, you can just probably barely see it on the wall. There's a dimmer there. So the dispatcher can adjust the intensity of the light in his space. So a lot of the dispatchers like to run in a dimmer room so they can see the board really well and not quite so stressed or blinded by the lighting going on. So we have a room kind of pretty well done. We have a tabletop. We have a railroad that's fairly well built or being built, so we know the track design. Now it's time to start designing our panel. So the panel on the right there, those are the panels that are down off the SSW. And me and my son Joel went down and studied them and photographed the daylights at them and took measurements. I also was fairly lucky because I had several CTC pan plans that came from the Santa Fe when I worked in the engineering department. They were getting rid of a lot of the stuff and I would just fish it out of the trash or whatever. And so I had a really nice dimensioned CTC panel design for a USNS panel from Isleta, New Mexico. And you can see it there to the left. And that nice thing about that, again, is the dimensions on it, which was allow us to make things correct. We studied a lot of prototype panels. Again, they're usually trashed out, dirty, weathered, nasty looking, and they've usually been reworked. They've had trackage removed, and normally These are etched aluminum panels. So normally when trackage is removed, they just take a piece of electrical tape and just stick it over where the track was. So they're quite an interesting feat of engineering over time. So for the model railroad, the first thing to do is to map out your railroad. So this obviously has an east and a west end, and you can see the large staging yards in the upper left and the lower right-hand corners. And then you can see the track work that is going to be affected by our signaling. In other words, that our signaling is actually going to control. And there's a lot of other trackage on the railroad, a couple branch lines and things that are not signaled. They're not shown on the panel. The only thing you will see is you'll see some dotted lines on that panel. And what those dotted lines are is those are yards or non-signaled areas that the CTC dispatcher is going to have to interface with. If you remember earlier, we had a conversation about how the yard is not allowed to dump trains out on the main line, and the dispatcher is not allowed to dump trains into the yard. So there's at least 5 or 6 of those areas on the railroad where the two authority figures have to ask for permission from the other one in order to get the train to move between the two authorities of the territories. Those areas are shown on the panel. And they are the non-signal territory, or the yard areas are shown dotted lines, and of course the solid lines are the main lines. So you can get an idea of how the layout would lay out. This also has signals shown at the different locations, and it has the block boundaries also shown, which are little slots in the track. We'll get into this a lot later, because this is your initial piece of design that you're eventually going to work from to design your panel. I did everything in Adobe Illustrator. It's a vector program, and you can create exact looking pieces of hardware for your railroad itself. We'll talk about how we actually turn this artwork into a physical panel off of a screen. Now, a lot of people will be using screens to operate the railroad. That happens a lot. We, however, chose to actually build a panel just because of the extreme realism of an actual panel. So this is the plate artwork. These are the plates that are for the switch levers and for the signal levers. These were all designed and numbered separately, and then they were printed out on a vinyl sheet. And part of the printing process is we had a printing press that would actually cut around the knobs and levelers and plates. So basically what we ended up with a sticker sheet. So we ended up with a sheet that had really high quality vinyl stickers. While we were doing this, we also did field plates for crew ID. In other words, here's the sidings, here's the industries, any information that we would want the crews in the field to have. So we did all this at the same time. And if you look on the railroad, you can see some of those. In fact, between Keith Robinson and Jacob Dittmer's there's a couple of those plates. You can see them on the fascia of the railroad. We wanted to make sure that everybody was out running, could be informed very clearly as to where they were, which direction was east and which direction was west, so that they could basically, a crew that had never run across the railroad had enough information to do so successfully. Here's a close-up of that, the field plates for crew ID. You notice this is the east end of Brusky, and then this is a siding switch. So that's kind of how those looked out in the field. And there's a close-up of the manual. You can take mainline turnouts into what we call hand throw. So if you're switching there, you can call the dispatcher, say, dispatcher, I need 20 minutes to set a car out at the elevator at the east end of Brusky. And dispatcher will say, okay, I'm going to put that turnout into hand. And he'd put it to hand, and then it could be controlled just like any other normal turnout on the railroad that could be controlled. The dispatcher turns that control over to the train that's operating. That has to be released when the train crew leaves. They have to turn that back over to the dispatcher and get rid of their track and time in that area. So, but you'll see how informative this is. And this is very, very easy to make on your computer and have printed out on a commercial industrial vinyl printer. I believe those entire sheets that I did only cost about 80 or 90 bucks. You cannot even get close to doing this with Chart Pack or any other method of painting these or anything else. I mean, it's just so fast and it's so nice to have. There's the actual vinyl artwork right there, printed out in large sheets, very, very rugged vinyl. self-adhesive. And again, when these were printed out, they were also cut around the objects. So basically you just pull off the sticker and stick them on the board, and we'll talk about that. I also made extras, so if I happen to mess things up, I would have some extras, or of course you can always go back and have anything printed, which is nice. You notice in this sheet we also have the staging yard diagrams, and they're kind of to the right of the image. Those large black squares are staging yard controls that will be on the down below in the ginger in the CTC panel. So here's the actual artwork of the layout itself. These are the panels, or the upper third or upper quarter of the CTC panel. These also were drawn and designed and cut out in vinyl by a vinyl cutting company. And part of that was they also cut out all of the openings for the light emitting diodes and everything. So when we pulled that piece off of the backer plate, it had all the holes in it and everything for the panel, which really made it nice. We also made a lot of auxiliary vinyl plates, such as where we had double slip switches in the lower right-hand corner. We made little routing diagrams that would show you how your slip switch was lined. We had a rotary switch, so as you rotate it, you could it would basically show you how you had the puzzle switch, double switch, slip switch lined, and that's very important. It helps crews, quickly identify things. Off to the left, there where you see the way car, the caboose, that is a signal repeater, and that signal repeater actually is for a set of signals that you cannot see on the layout because they're coming out from under a bridge and they're kind of far back where it's inaccessible. So instead of being able to read the actual faces, the actual targets of the signals, there was a repeater put in. And of course, it's very clear. It clearly identified this is Mosier eastbound signal. And of course, we did go ahead and put dummy signals up in the railroad too, because obviously the signals are your clearance points for your trains. So those things also ought to be done while you're doing your paneling design. So next thing we're going to do is we're going to talk about the case build. The case build was a little bit of a challenge because we were tucking it under a stairway, and so we had some weird angularity issues going on, but it was still fun to build. Pardon me for a second. So we built the panel out of MDF, medium denser fiberboard, with a sanded outer surface. This is what a lot of cabinetry and kitchens are made out of. And so it's readily available. It's fairly easy to work with. It was glued and brad nailed together with an air nailer. The openings and things were routed with a router. Everything was sanded after assembly. Then things were painted black. And the nice thing about MDF is it holds fasteners really well. And if you choose to, and we did, we went ahead and laminated black formica to the outer surface of it to make it more rugged and easier to clean and far more scratch resistant and scratch proof. So here you can see underneath the stair, you can see the stairway coming down there. You can see the room is kind of done. The flooring is done, the wainscot and the desk. And you begin to see we're building the case underneath the stairs. And it was an L-shaped case, panel case, with a 45-degree corner in it, which is pretty typical for CTC panels. This is kind of a standard CTC design. On the left image there, you can see how we angled off the top of the case itself to clear the stairway, and then the end of the case sticks out beyond the stairway, so it has kind of a square appearance. Also, I want to point out in both of those images, behind the Adlake lamp and kind of on the left-hand side, there's a horizontal black box. That is actually a PC computer. It is a rack mount PC, and we went ahead and chose that type of computer to run the CMRI, and because it's an industrial rack mount computer, and it worked really, really well. So case design requirements. So your case, just like your room, is going to need certain things to make it successful. First of all, it's electronic, so it's going to make some heat, so we want to provide airflow. We want mounting places for electronics. We're going to have all kinds of detector and driver boards in this, so we wanted to make places for those. We wanted to make, obviously, a place for the rack mount computer, which I talked about. we need plenums or openings for wiring harnesses. We're going to have wiring running through there, and so we want to make sure we think about where that's going to be up front. We want really good mounting places for hinged face panels. In other words, the panels themselves with the levers on them are going to be hinged so we can open them to do maintenance or cleaning or repair work. Obviously, we want it to look good. We don't want a cardboard box, with something taped across the front of it. And then we want it to have internal lighting within the case to facilitate our wiring. We're going to be pulling a lot of wiring inside that case, so we put internal lighting in it as well. And then, of course, extremely solid construction. So we built the case outside, and we did this on a Saturday morning, me and Keith Robinson. Keith is an incredible Kansas City modeler and a fantastic guy. And we basically all the things I talked about are being shown by those little pink arrows. So the case was cut and built in flat sections. All openings were routed with a quarter round routing, so they had a nice smooth kind of lip on them. And then those things were all mounted in place, glued and shot together with an air nailer. So we have a lot of wiring pigtail holes you'll see that run through there. We have fan holes. The pigtail holes for the wiring also were large enough that they served as the ductwork or the plenum for air to move through the case. And then you'll see the wiring holes in that weird kind of looking shelf in the middle with all the smaller holes. You're going to see what its purpose was here shortly. So here's another picture of the case mount. Obviously, we've got some shelving in there. We have some wiring holes, some plenum areas. Why we were building the case that was going to be visible, we went ahead and put some USB plugs in it so you could charge phones or anything. Also, you could do some programming to and from the panel if you needed to. And then we had a really nice rack mount CPU opening there for the panel as well. The left image there where you can see the interior shot, you can begin to see the plenum holes through there. And again, that's where the wiring is going to run, but those are also ducts for air to move through the panel itself. Now the panel didn't get super hot, so we used fairly quiet, low RPM motors, but the key was just to make sure we had air moving through the case. That's the biggest, and we're not creating a sealed case that we can get heat buildup in. So one of the mistakes I made actually is in painting the interior black. If I would have had my brain turned on, I should have actually painted it white because it would have, you can see the interior lighting in the case, but it would have been much easier to increase the visibility, us seeing where things were, if indeed the inside of the case would have been painted white. Now that wasn't a make or break deal, but if I ever do this again, the inside of the case will definitely be white because of that simple fact. But we painted it black in this case. So again, you can see the wiring holes. You can now begin to see things occupying the shelves and things within the CTC panel. We have a very large computer power supply in there. We have a couple major boards in there, and then we have some racks of removable boards. These are basically can be plugged in and pulled out so that they can be replaced, repaired, and or be left somewhat modular in fashion. This is my incredible son Joel. You can see in this picture all of the wiring that is in one of these panels. And you'll see how all of those, the holes, the plenum holes, not only allow air to flow, but they also allow wiring to be run through the panel. Here you can see that horizontal shelf above the PC boards. PC boards set in there kind of like books on a shelf, plugged into a backplane, and then the wiring plugs into the front of the board, and the wiring goes up through the holes and out to the PC boards in the machine itself. Oddly enough, this panel, all the wiring in this panel just stays in the panel. Everything, the only thing that leaves this panel is, I believe it was 5 wires that left and went out to the railroad, because those 5 wires were communicating via computer language. And so all this wire is isolated only in the panel. It only goes from all the rotary switches and light-emitting diodes to the PC boards themselves. If you look at the gray wire there, kind of to the left of Joel, in fact, it's just gray wire right. Let's see if I can get far enough there. Right there, that gray wire, that's the actual wire that goes out to the railroad. That's all that goes out and runs around on the railroad itself. This is the communications board right here, and it is what is going to transmit and receive all the data from all the signals out on the railroad, all the turnouts, all the grade crossing detectors, all the track detectors, and everything, and bring it into the board. Incidentally, we did not invent this system. This is Bruce Chubb's CMRI system, which in my opinion is one of the best things that ever happened to model railroading because of what we're doing here. Okay, so we have the panel built, we have it physically in place. Now we need to design and size, more importantly, the front panels, the front actual flat panels that are going to hold our physical switches and our light emitting diodes and our graphics. So we're fortunate enough, we have a large format printer. There's large format printers anywhere. You can go to Kinko's or any place and have these things printed out in 100% size. So you can see, oh, I'm a little crowded here. I'm going to move everything to the left a little bit, or I'm going to move it down or up a bit. So you have the opportunity with the layout of your panel actually to make sure that things fit by printing out an early version, kind of a template of what your panel will look like. So we now have our graphics designed, and we're going to make our panel itself out of I think it was 3/8 inch, maybe it was 1/4 inch ABS plastic. ABS is fantastic. It's very strong. It drills very easily, and some people will make it out of aluminum, but and you can do that obviously. We chose to do ours in ABS, which I'm glad we did, because there's some things you can do with ABS, which I'll show you. You can glue some stripping onto the back of ABS that then becomes basically mounts for wiring harnesses, and I'll show you wiring pigtails. We'll show you that here in a while. That's the main reason for using ABS. So you see the artwork that's going to go on the panel here, the switch and signal indicators, hot box, and then some lock indicators. As I mentioned earlier, clear to the right, that's a dimension sheet that I got from the Santa Fe Railroad that has the dimensions for the controls, and then the middle there is going to show what we're going to put on our panel. And so from the top, you have a diagram of the railroad, you have a call-on button, controls for your switches, controls for your signals, a power off, an OS bell, a fleet mode, and then a code button. And those things are what we were going to put physically build onto the panel. They look like this, kind of what happens, and you'll notice there are a lot of holes to drill. And so one of the challenges early was, okay, we need to do exactly what they did with the real panels, and that was I believe it was every 2 inches, they would drill a set of holes from top to bottom that were identical to do this. So what I did is I took a sheetrock square, an aluminum sheetrock square, and we marked it and drilled out holes that became a template for the CTC panel. And then we would just run that sheetrock square across the railroad and drill holes through it to make all of the holes. And I know you're like, I don't know what you're talking about, Steve. You'll see it here in a minute, because the holes in their positions are completely repetitious across the whole face of the CTC panel. And so we would drill a pilot hole, and then we would go back and we would actually drill the larger holes. By the way, when you're drilling plastic, please go out and get some plastic bits that are made for plastic. They have a different tip shape, and they're far better than trying to use a metal bit or a wood bit. They have a very sharp, steep point on them, and they cut your plastic much, much better than any other drill bit. So we drilled, I didn't even count the holes, but I bet there's 900 or 1,000 holes on there. On that left image there, you can see the machine being drilled, and we're drilling out the face panels for the CTC panel. So when all the holes were drilled, and you end up with a sheet that kind of looks like this. You end up with all the holes drilled into the sheet, and we painted the front of the panel, the ABS, with a plastic paint, olive drab. And the reason most of the CTC panels were olive drab is because this was during the war when they were building a lot of these. And olive drab was a paint that was very inexpensive and obviously readily available. And again, the back of the panel was painted black. So there we go. Here are the 3 panel pieces after they have been drilled with the drilling template. and you can see, wow, that is an awful lot of holes. The cool thing about this is you want to go ahead and drill all the holes, because the holes that you don't use when we put our levers and leads in will actually be plugged. And we'll show you that here in a minute, how they're plugged. And this is the way the prototype panels were built. So we made our graphics earlier, if you remember. We made them out of vinyl, and we now need to add those to the ABS plate that we have just painted. So this is what things are going to kind of look like when they come to fruition, that left image. And on the right image is the vinyl still stuck to its backing. Now again, if you remember, all the holes for the direction indicators, turnout indicators, occupancy indicators were all cut on the printer itself as these were printing. So it prints and cuts those holes out at the same time. So this thing, literally, you can peel it off the sheet and stick it on the panel. Now, I'm going to teach you a trick here in a minute, I guess, after we talk about the graphics programs and things, on how to put the graphic arts onto the panel. So again, here's a shot of one of the sticker sheets, basically the vinyl sticker sheets. This was all drawn in Adobe Illustrator, and when you do this, ladies and gentlemen, you want to use what's called a vector graphics program. You don't want to use a paint program or anything that uses pixels to draw. You want to use a program that uses vector. In other words, the shapes are described mathematically, not by the position of pixels. So do not use Microsoft Word, PowerPoint, Paint, Excel, or any of these other programs that you can draw graphics in, but they're all bitmap. In other words, if you enlarge the graphics on them, you can see individual pixels. You're going to get a panel that's going to look terrible. So I'll just let you know up front, if you don't know how to use Illustrator, find somebody who does, hire somebody to come over and work with you or whatever, and get your panel drawn, because you want your panel to be very professional. You're spending a ton of money on this thing and a ton of time on it. Let's knock it out. Let's make it knock it out of the park. So now we're going to go back to what I was going to talk about earlier with the sticker sheets. So I would pull the lower left-hand corner. I would pull the whatever I was going to be sticking onto the plate from the backing, and we would spray the fascia of the CTC panel with soapy water. So then you can lay the vinyl onto it and slide it around until it's located perfectly, and then you just blot it off with a rag or a blotter. And once you do that, it will stick to the sheet. The water evaporates out of the back, and you've got a firm bond. The nice thing about using the soap method to do this is it allows you to move stuff all over the place until it's perfectly true, straight, and lined up with the holes. And this is obviously the switch and signal levers were a lot easier than the main track diagrams. The main track diagrams took 2 people to do, but they were done the exact same way. They were done with soapy water and sliding them around on the sheet. And here you can see that they generally took 3 people to do that. And here you can see we've sprayed the board down. We're taking a large piece of artwork, pulling it off, and then putting it on the fascia, sliding it around until it's all located perfectly, and we're good to go. And so it was a lot of fun to do, really, and it was really cool seeing the CTC panel take shape. So here it is with the kind of the water method. You can see me kind of doing a little bit of squeegeing there of some of the artwork. When it's done, you basically have a really nice looking panel, super professional looking, that was very inexpensive to make, and is done by a method that is really considers your time. In other words, you're not making separate plates out of metal or trying to have stuff etched or trying to paint things. There are commercially available signal and switch levels. Rix makes them, but you have to paint them, and you have to go through a lot of work to get them to look good. And we're going to use some Rix parts, which we'll talk about here later. But for the signal and switch levers, we went ahead and used the vinyl. So let's talk about hardware a little bit. One of the things that's going to happen now that we have all the graphics on our panel, is we're going to start installing hardware. We're going to start installing large light emitting diodes, their mounting points, rotary switches, and obviously switches, on-off switches, SP, or single pole double throw switches, or single pole single throw switches, ST switches. You also notice if you look at the panels there are a bunch of blank holes that are going to be patched. There are a bunch of holes there that will not be used, and we'll plug those here after a while. So we spent an afternoon putting light emitting diodes in and then putting rotary switches and switches in. As I mentioned earlier, you can buy panel plugs, and these panel plugs were actually purchased. They were painted the same color as the fascia on the layout, allowed to dry, and then they were just pushed into the blank holes exactly how the prototype did it. And you can see some of those in place now on the panel as we built the panel. You also notice a lot of the switches are in now. The rotary switches were in and awaiting their appropriate knobs at this point. Now, this is what the panels look like in back. And I mentioned earlier that one of the reasons I used ABS is because I wanted to put strengthening bars in the back, but I also wanted to use those bars to be able to make bundles of wiring that run into a horizontal fashion across the back and into the panel. You can make these panels with wiring just running all over the place, but it's far better to make some actual wire guides to guide the panels. So this is what your panel is going to look like in the back once you get your switches in and a lot of your rotaries in at this point. And then at this point we start wiring, and you'll notice the first thing that went in on the left-hand image there, that's Keith Robinson. Keith Robinson has already run his ground buses through. This is basically just, I believe, 16 gauge copper house wiring. You'll see that they're just running through holes in that background strengtheners. On the right-hand panel, John DePaw. John is from Michigan, and John came down and with Bill Carr and worked on the panel. And you can see we're tying, basically just like an automobile, we're tying half of all the electrical components to a ground. So that way we only run half the wiring into the panel, because half of all the light emitting diodes, switches, everything goes to a ground, and then we run one other lead in to illuminate or register how turnouts or switches or rotaries are set. So that's what they're doing there. Here is the beauty of using those vertical bars and those horizontal bars that are glued out of ABS. They're ABS strips, basically 1.5 inches tall, glued to the back of the panel. It gives the front of your panel strength, but it allows you to do a beautiful, really nice job of wiring your layout. So everything goes through these horizontal, basically pigtails we call them, and there's wire tied to the frame. The nice thing about this is the wiring itself is in different categories. The very top braid is light emitting diodes, and you have a middle one, which is some more leads. You have the next one down, which is rotaries, and on and on and on. So basically there are different classifications of braids that come off of the panel. So when you start wiring this on the other end, you don't have to basically struggle through every single wire on the panel to find out what you're looking for. They're already sub or pre-classified by how they're wrapped. The panel knobs, these we actually use Rick's knobs. Rick's knobs fit on standard rotary switches, and they really, really look good. You can buy metal knobs for this, but I never saw any reason for that. We took these and basically painted them with a metallizer paint, so they looked like cast metal that had been chromed, and then we hit them with a very durable acrylic final finish, and then let them sit out in the sun for an afternoon, and they really look good. So basically what Joel's doing there is he's pushing those knobs onto place on the panel, and you can see the panel's even lit up at this point. Certain functions are lit up, and he's messing with the panel itself. When we were building the panels, there were 3 panels, so I built one, John DePaw built one, that's John there to the left, with his prized possession of a panel, and then Keith Robinson did the other panel. So that's what they look like when they're finished. They're modular, they can be lifted off the railroad and moved onto the actual panel itself. And then Bill Carr is the gentleman sitting there with the pigtail in his hand. This is the pigtails being pulled in from the panels themselves. Those wires would then be routed to the correct board, and they would be cut and put into place. So worked quite well. A couple other things while we're talking about this panel. The panel John DePaul has, if you look down at the bottom, there's a fast clock built into the panel, and there's a controller for the fast clock too. Down below in the panel itself, in an area which is often referred to as the ginger in the panel, all kinds of things showed up on prototype panels. I mean, all kinds of telephone systems and indicators and buttons and all kinds of things. So it's not uncommon to have all kinds of weird stuff show up down on that very bottom. That's where we put the staging controls for the railroad, and that's where we put the fast clocks, signal indicators, and some other things, or code indicators that allowed the operator to know the code was going out and coming in from the field. Here you'll see the wiring pigtails. They're quite amazing. Again, you know what you've got right here. You've got the boards, the detector and the driver boards are right here, and then these are pigtailed and wired out onto the panels. And the panels have a hinge on them, so they can be opened up for maintenance. The hinge is back in this corner, and then of course the board up here is numbered. You'll notice it has numbers on it for organization. These wires then run out to the layout. To the other panels on the CTC panel. Again, the only thing that's going to go out to the layout is going to be one wire with 5 conductors in it. So the entire panel gets its information and provides its information through 5 wires that receive and transmit data. So the panel now is looking pretty good. It's kind of roughed in. It's not screwed in quite yet. It's still sitting free, so we can tweak it. We're still working on it a little bit. You notice we have some of the plugs in, but there's still open holes through it that we're going to have to stick plugs into. You'll notice down below along the ginger here, we've got all the controls for the staging yards. This is the staging controls. There's a rotary switch right here and on the other end right here that are used to line the switches in through a diode matrix into the tracks. And we also have occupancy lights that'll be on this, as well as lights that will show what track is lined into the staging yards on each end of the railroad. These are indicators right here that indicate the code signal going out and back. They really aren't that important in a model railroad, but a lot of the prototype panels had them. Also, we had relays in the machine that clicked because there's certain click panels as the relays send signals and the prototype panels out to the field. Again, this was all analog electronics. We're using digital electronics to run it, but the original systems were analog, so there were a lot of relays, so you got relay clicks, so we had relays in the boards as well that clicked. So we mentioned earlier lighting. Lighting was a very important part of the CTC panel. We put in dimmable lighting. You can see over to the left there where the TV screen is. That's the back wall, and there's a dimmer switch there. Incidentally, my son, being an aggressive modder like he is, wanted to take and put a window in the CTC room in the depot or in the CTC building. So we mounted a bunch of small cameras all over throughout the railroad, and we put a video select box, and then we mounted a TV in the wall like a window, and made a little threshold for it and outlined it with wood, so you got the appearance of a window. The only thing that we didn't get done on that at this point was we didn't get the mullions in, the dividing mullions, so it did look like a window. That would eventually happen. Also in that image, you can see the lighting, and you can see the train sheet, the train sign-up sheet for crews. This is kind of another view of the crew lounge in the house and the notch for the CTC panel. Again, you can see the stairway coming down, and then it opens up into the room at the bottom, and then you can see the really nice burlwood desk with the kind of bulbous end on it where all kinds of paperwork could be stored. At this point, Joel and Bill Carr were still programming, so there's actually a monitor sitting there and a bunch of paperwork. All that eventually would go away, and that would all be kind of freed up for desk space. So it became a really, really nice, visually appealing area. And if you look at the lighting in the room, the lighting could all be dimmed down, had that nice ADLAC lamp on the desk there, and it was a nice area. You can also see the ventilation. You see the ventilation shaft or the ventilation down next to Joel's knees there, and the hardwood floor, and then the wainscot with the chair rail in the room itself. So now these things, guys, obviously aren't necessary to have a CTC panel, but man, if you're doing this, just go all the way, do it. Do a nice job with it. and finish out the room. Here's another shot of it. A couple more shots. There's Dan Munson in the left hand, the smaller picture. Dan Munson was dispatching, and that's a BNSF conductor, actual real conductor, Travis Bastian, getting his information, train orders. Dan is telling him where his train's at, and he's going to go out and hop on his train and run it across the railroad. So a good, comfortable chair is also nice to have in your dispatching area. As you can see, we've got a nice little chair there. Another shot of it. Now, get off your computer and go build something. The panel itself took about, the CTC actually took itself, the panel itself, the physical part of that, actually took about 6 months to build. We were able to finish the construction in about 6 months with that. So it worked really well, and we were super, super happy with it. So I guess at this point, we've got some questions. So we're going to get in here and take a look at some questions here. What improvements or innovations can be expected in the future iterations of CTC technology? Well, I tell you what, electronics are really, really, really going well, as you guys know. Just look at what we have in our, in our cellular device. It's amazing what we've got. I think there are some companies now. Bruce Chubb is getting up in years who makes CMRI. There are a couple other companies that are now making CMRI components. I know that there are some newer versions of detectors, block detectors made, and other things. The NMRI also has an initiative, which I was part of in years past, called LCC, or Layout Command Control. LCC, it does for the rest of your railroad what DCC did for the operation of your trains. LCC is a bus that allows communication between signaling, lighting, displays, anything you want to run separate from train and traction control. So there's a lot of signaling components being made now for LCC. So you're probably going to see a second generation of signaling systems coming on board. How do people manage potential failures or system malfunctions? It was shown yesterday that there are some heaters for signals. Yeah. Well, I'm going to assume you're talking about the model instead of the prototype, but the nice thing about building the modular system is if you saw those cards that were like books lined up in there, those cards are removable and quickly programmable with some dip switches. So if you're having issues, something is not working, you can quickly swap out boards, reprogram them with the dip switches, stick them in. Oh, it wasn't that one. Until you find either the failure board or the section of your layout itself where you're having failures. And then you can quickly replace them. That's the beauty of the modularity of the system. And it's all modular, all clear out through the whole system, because this entire system runs off of 5 wires. I mean, literally 5-wire bus runs around the railroad, and everything gets tied into that, as opposed to running hundreds and hundreds and hundreds and hundreds of wires. Wow, what a nightmare that is. Jeremy said, the window idea is awesome. It makes the experience more immersive. It really was. When the panel got built underneath there, my son was always like, Dad, I love the railroad, but I feel separated from it. I feel removed from it. And so we started thinking about, well, how could we fix that? And he said, well, why don't we, little cameras are inexpensive and televisions are inexpensive. Why don't we kind of make a window? And so I left him to that project, and he actually put all that in. And it was really cool. It was really cool. Can you supply parts numbers for rotary switches, LEDs, and LED mounts? I can't off the top of my head, and I'll tell you why. If you're interested in doing this, Bruce Chubb through CMRI actually sells books, and they're not very expensive. They're just a simple wire-wound photocopied book. But in those books, he lists all of his PC boards, all the components to make the boards if you actually want to buy them as components or buy them as kits. And then he also has all the parts listed. There's also a company called, I think it's called CTC Supply. And I apologize because I don't have that information on me, but there are people that make these devices and things for purchase. But everything, almost everything, is listed in Bruce Chubb's relatively expensive books that you can go out to Computer Model Railroad Interface on the internet, look him up, and he has lists. He has lists literally of everything clear down to every bolt, washer, and nut that you're going to need to put this stuff together. Bruce is a godsend to this hobby in this manner. We also ran when I was editor of Railroad Model Craftsman magazine, we also ran I was like a 16, 17 part series on adding signaling to your railroad. And there's a lot of this information in that series as well. There's far too many different parts numbers for me to list here, but there are good sources out there. And if you want to drop me a note at stephen.priest@class1modelworks, all one word, .com, stephen.priest@class1modelworks.com. I will do a little bit of research and dig up those sites for you, and I'll have those ready so I can send an email to you to see where to get the components. The stuff's readily available, and it's not particularly expensive. Let's see, what font did you use for the model board? Pretty much Helvetica, a Helvetica Bold. Helvetica was a very common font for CTC panels. Again, pardon me, you can go out on the internet and you can search CTC panels. You can get some pretty good photographs of those. If anybody's interested too, I'll be more than glad to send you an AI file that has all this stuff on it. I have these files still. I can just outline them and send them to you on an email or whatever, and you can actually have all the artwork. I'm not trying to hoard anything. I want to definitely make sure anybody can build anything because it's super important. Rough cost for the hardware, software for the project. Well, there's a bunch of ways to do this. We built almost everything as kits. In other words, we bought the PC boards from Bruce and or other people, and we had little parties, me and my friends, where we sat in the shop and stuffed, soldered, and tested boards. So, pardon me. So all of our electronics we actually built ourselves, and then a good friend of mine, Joe Casper, works for a company where they have a lot of leftover wire, so I didn't pay for wire either, so I got a lot of wire bundles that we used on the railroad. So those things were quite helpful to build the panel with. So the question was, how much did it cost? I think the entire project, MDF, everything, the computer, everything, I think it ended up costing around $6,000 for the entire project. And that includes signals. Now, I'm going to tell you, this was an enormous railroad. It's a 3,500 square foot railroad. And I mean, there was like 40 signal locations in each direction. So there were a total of 80, 40 eastbound, 40 westbound signal locations. I mean, there's a lot of signals. And the signals made up a major portion of that. When BLMA was still in business, I went to him and negotiated. I said, hey, I need to buy a lot of signals. And he gave me a special pricing because I bought all the signals at once from him, and then went on down the path from there with the signals that I had bought from him. So let's see what else we got. You guys are welcome, man. I really appreciate it. I know CTC and signaling is kind of a weird thing, and not a lot of people are ever going to do it, but it is for the people that really want it. It does a lot for your railroad. And I tell you what, it does a lot for your railroad. The complete and total nature and flavor of your railroad changes when you put a CTC panel in, because it really comes to life in ways you never imagined. You run far more trains, far more efficiently, far quicker, and your crews have such a good time reading their signals and getting the information from the signals. There's nothing like being out on the main line, coming up on a flashing yellow and then a yellow, and then a low yellow and going into a siding. You know where you're going to go. And I was an actual locomotive engineer. It's a thrill to do that on the prototype, and it's a thrill to do that on a model railroad. It really is fun to run on a signaled railroad. It's an absolute blast. And the dispatchers had a blast too running. My wife used to love dispatching, and my son as well. So, all right, CTC parts, yes. If there's any no more questions, I guess we'll move on. So it looks like we're good. I'd like to thank everybody. We're going to continue to do these live streams periodically. If you just pay attention to them, we will announce them periodically. and we'll have a blast. So thank you all for tuning in.